Welcome everyone. I'm Abhisha with my group members Parkavi and Sathya Prakash. We are here to present a video on types of powders, especially hygroscopic and EUTECTIC mixtures. As the agenda of this video, we're going to see about the introduction of powders, types of powders, mainly hygroscopic powders and the EUTECTIC mixtures, and after that is the preparation. So before starting anything, we should know about what a pharmaceutical powder is. So, a pharmaceutical powder is defined as a dry solid substance composed of finely divided drugs with or without excipients and intended for internal or external use. It is a solid substance in finely divided state typically obtained by crushing, grinding or comminuting. So, its properly prepared powder have a uniform small particle size varying from 10 nanometers to 1000 micrometers that has an elegant appearance. In general, powders are more stable than liquid dosage forms and are rapidly soluble, enabling the drug to be absorbed quickly. So, now we are going to see about types of powders. Let's discuss about types of powders. There are several different types of powders available in the market. So when we speak about types of powders, the first type that you can see is the powders for external use. The second one is powders that is based on nature. Third one is the special types of powders, and the final one is going to be powders for internal use. So when we begin, the first one, powders for external use, they are divided into 4 types, and they are densifiers, dusting powders, douse powders and insulation powders. The second one is the powders for internal use. They are divided into 2 types, and they are divided powders and bulk powders. The third one is the powders that are based on nature. They have 3 types, and they are dye powders, hygroscopic powders and deliquescent powders. And the final one is the special powders, and they are divided into 2 types. The one is EUTECTIC mixture and the other one is effervescent powders. And now we are going to see about the main topic, that is hygroscopic powders. What we see in this picture is a hygroscopic compound which we commonly use in our laboratories. Guess what? It's NaOH, that is sodium hydroxide. Now let's see the definition of a hygroscopic powder. The term hygroscopic means that these substances can absorb water from their surroundings. The water molecules in hygroscopic substances are absorbed into the crystal structure when water vapor is absorbed. As a consequence, the size of the substance increases. A change in hygroscopic properties can be seen in color, boiling point, viscosity and others due to the hygroscopic nature. The examples of hygroscopic powders are NaCl, zinc chloride, honey, silicon, germinating seeds, etc. are among these gel compounds. Now this picture clearly shows how the moisture is absorbed into a powder. In the first one, the water molecule, that is H2O, is not entering into the compound because there is an equilibrium moisture content in the atmosphere. In the second image, water molecules are tended to absorb on the compound. This happens because the relative humidity in the atmosphere is higher than the material's equilibrium moisture content. And now, in the final picture, here the moisture content in the material is tended to release onto the atmosphere because the relative humidity in the atmosphere is lower than the material's equilibrium content. And these are the processes how the material turns into a hygroscopic compound. Now, because of their affinity for the atmospheric moisture, hygroscopic material might require stored in a sealed container. When added to food or other materials for the export purpose of maintaining the moisture content, such are known as the humectants, and the main humectant example is arsenic acid. Many engineering polymers are hygroscopic, including nylon, ABS, polycarbonate, cellulose, carboxymethyl cellulose, and polymethyl methacrylate, PMMA, plexiglass, and phosphate. Other polymers such as polyethylene and polystyrene do not normally absorb much moisture, but are able to carry significant moisture on their surface when exposed to liquid water. Type 6 nylon, a polyamide, can absorb up to 9.5% of its weight in moisture. Let's perfect example of hygroscopic powders, and that is the bleaching powder. And now, the bleaching powder is another example of a hygroscopic powder. The structural formula of bleaching powder contains two atoms of chlorine. Among these two atoms, one of them is properly bonded to the atom of the chemical compound calcium. The other atom of chlorine results in the formation of a bond with the atom of oxygen. Now we'll see the preparation of a bleaching powder, that is how it's prepared. In this, the entire system is prepared for the manufacturing of bleaching powder, containing a vertical cast iron tower packed with a hopper at the top, two inlets near the base, one for chlorine and the other for hot air, and an exit for waste gases near the top. This tower is then fitted with shelves that are placed at varying heights with rotating legs. The shelves are total of 8 in number. Flaked lime is introduced into the hopper. It eventually comes in contact with the chlorine, moving slowly in the upward direction. The bleaching powder is then collected at the base in the barrel area of the tower. Let's see an animated video of how the bleaching powder is made.
For Bachmann's process, dry slaked lime is used as a raw material which is fed into the tower from the hopper at the top. A current of chlorine gas is also provided at the same time from an inlet at the bottom of the tower. As the shelves inside the plant rotate, they take the dry slaked lime downwards. During this downward movement, the dry slaked lime comes into contact with chlorine gas, which is moving from bottom to top. The dry slaked lime, which is chemically calcium hydroxide, then chemically reacts with chlorine gas and forms bleaching powder and water. The bleaching powder is then collected in the barrel placed at the base of the tower. To remove water, which is the byproduct of the reaction, a current of hot air is introduced in the tower through the other inlet. The hot air drives away the water as vapor along with unreacted chlorine from the outlet at the top of the tower.
Now let's see about the next topic, that is EUTECTIC mixture. So, what is the definition of a EUTECTIC mixture? A EUTECTIC mixture is defined as a mixture of two or more components which usually do not interact to form a new chemical compound, but which at certain ratios inhibit the crystallization process of one another, resulting in a system having lower melting point than either of the components. EUTECTIC mixtures can be formed between active pharmaceutical ingredients, or between active pharmaceutical ingredients and excipients, or between the excipients, thereby providing a vast scope for its application in pharmaceutical industry. EUTECTIC mixture formation is usually governed by the following factors. The first factor is the components must be miscible in liquid state and mostly immiscible in solid state. The second factor is intimate contact between EUTECTIC forming materials is necessary for contact-induced melting point depression. Third factor is the component should have chemical groups that can interact to form a physical bond, such as intermolecular hydrogen bonding. The fourth point is the molecules which are in accordance to modified Van Hoff's equation can form EUTECTIC mixtures. The problems that are normally arising during the formation of EUTECTIC mixtures are mixtures of substances that liquefies when mixed, rubbed, or titrated together. The melting points of many EUTECTIC mixtures are below the room temperature. Let's see the solution for this problem. The first solution that is using inert absorbents such as starch, salt, lactose to prevent the dampness of the powder. The second solution is dispensing the components of a EUTECTIC mixture separately. Let's see the further examples of a EUTECTIC mixtures. The examples are menthol, thymol, phenol, and camphor. Now, before anything, we should know the EUTECTIC temperature. The EUTECTIC temperature is the lowest possible melting temperature for all mixture ratios of the constituent compounds in the EUTEC oil. The superlattice will expel all of its components at this temperature, and the entire eutectic structure will dissolve into a jelly. In contrast, in a non-eutectic mixture, each part can solidify into a lattice at its particular temperature before the whole substance solidifies. Where a eutectoid is a stable mixture that occurs when two or more molten metals are cooled to a certain temperature. An example of eutectic temperature is sodium chloride and water combined to form a eutectic mixture with a eutectic point of 21.2 degrees C and salt content of 23.3% by mass. Now this is a perfect example of the eutectic temperature of two components, namely component A and component B. Here, the alpha means the eutectic temperature of component A and the beta means the eutectic temperature of component B. The L is a eutectic point where the two components melt in together to form a uniform mixture, and alpha plus beta gives the eutectic composition. Thank you for paying attention to our video, and I thank you on behalf of my group mates Parkavi and Sathya Prakash. Thank you.